Hello and welcome back to AGT STEM. Today we're going to be watching a video about gadolinium. So, without further ado, let's hop to it.
Okay, so gadolinium is smack bang in the middle of the 4F series. It's perhaps most famous for the fact that it's used as a contrast reagent in MRI machines. So if you need a full body scan, a doctor will come along and inject you with a solution which it contains a bit of gadolinium. And what it basically does is it changes the way that molecules, water molecules react in your body when they're scanned. And then you can see the contrast between healthy tissue and perhaps unhealthy tissue, and then that aids the doctors in their assignment. The thing about the lanthanide series is that it's probably the best example of a smooth contraction of size as you move from the left-hand side to the right-hand side. And you lose about 25% of the radius of the atoms as you move from left to right. And this is called the lanthanide contraction. This is actually what's responsible for second and third row transition metals having very similar types of chemistry by group, even though actually they should be quite different. The third row should be much larger, but because of the lanthanide contraction, that increase in size is counterbalanced, so they actually end up being more or less the same size as their second row counterparts.
Even chemists sometimes wonder how people can get excited about particular parts of chemistry. And the rare earth elements are elements which those who are not working in the area don't always see why it can be very exciting. So when I was a student, I saw an advertisement in the lab where I was working about a lecture about the oxidation states of the rare earths elements and the relative stability of two of the oxidation states by a chemist called David Johnson, who in those days worked for the Open University. And I went to this lecture because I couldn't imagine how anybody could make it interesting. And it was really fascinating.
I can understand how some people can not be interested in chemistry, because to a lot of people it just seems boring, just like any other class in school or like any field of work is just completely boring and you don't really want to do it. But chemistry is so interesting in reality. There's so many different things about it that are super cool and super fun.
He was so enthusiastic and so on. By the end, I rushed out really quite excited. In fact, I went and bought this book, which has been sitting on my bookshelf ever since, and has been quite useful for teaching some of my students.
Thank you so much for watching, and we'll see you next time. Stay smart. Bye!